Hey guys, today we're going to do our second day of pre-calc. We're going to learn how to find the inverse of a function and also prove that that inverse is in fact the inverse. So we're going to start with number 3, letter A, which is a quadratic. The most basic thing you do when you're finding the inverse is you switch x and y. So y, f of x is of course y. So I'm going to make this an x, and I'm going to make these x's y's. So that really is the inverse. But the bulk of your time is going to be spent getting this to say y equals. So to do that, let's isolate the y terms. I'm going to subtract 5. And now here's the hard part. Since you have two y terms that cannot be combined, we're going to do this cool trick called completing the square. To complete the square, you're going to take the coefficient of the y to the first term, -4 in our case, divide it by 2 and square it. So that is a 4. -2 squared is 4. I'm going to add it to both sides. The beauty of that is that creates right here a perfect square trinomial, which is not only factorable, it is something times itself. In our case, y minus 2 times y minus 2. But the key part of this is that you're going to write y minus 2 squared. And on the left side, it'll be x minus 1. So again, we added 4 to the right side, the special number, so we had to also add it to the left, creating a perfect square trinomial that you could factor. Now we could get this to say y equals, because if you look, there's only one y term. Let's solve for it. Let's get rid of this squaring by square rooting both sides. And then finally, let's get rid of this minus 2 by adding 2. So we're hoping that the inverse is radical x minus 1 plus 2, which is known as f to the -1 of x. To make sure that this is the inverse, we're going to plug into the inverse the original function. And the original function and the inverse should undo one another, leaving you with just an x. Let's see if it works. I'm going to take the original function and plug it in here. So we have radical, and instead of x, we're going to have x squared minus 4x plus 5 minus 1, and then on the outside plus 2. Let's see if we get an x left over. So 5 and -1 is combines to give you 4. Keep in mind that this trinomial, just like over here, is factorable. So this is x minus 2 squared. The squaring and the square root, of course, cancel, and the minus 2 and the plus 2 cancel. So it did work. Let's try one more. This is going to be number 3C, and this is a fraction. So f of x is x minus 2 over x plus 3. We're going to start by switching x and y. Then we're going to try to solve for y. Now I want to get rid of this fraction first. I'm going to multiply both sides by y plus 3. And of course I could distribute this x here. xy plus 3x equals y minus 2. Now this one, well, let's keep going. Let's isolate all the y terms. I'm going to move all my y terms to the left and my non-y terms to the right. So I have only y terms on the left and non-y terms on the right. Now this is a little different than the last case. This one you do not have to complete the square because there's no squared term. You can't combine these, but if you simply factor out a y, that gives you a situation where you can easily solve for y because it's y times this stuff. If you divide by this stuff, you're set. Y would be -2 minus 3x over x minus 1. And in other words, this is f to the -1. This is the inverse. let's see if we came up with the right solution. So again, we're going to plug into the inverse, the original, in the hopes that we arrive at x as our solution. So our inverse, without any x's in it, looks like this. We're going to replace where the x's were with the original, x minus 2 over x plus 3. Now we have a crazy mess here. We have fractions inside of a fraction. To get rid of these fractions inside of this fraction, we're going to multiply everything by x plus 3. So if I multiply everything by x minus 3, that's legal to do in math. And the beauty of it is it cancels these fractions. So be very careful. Negative 2 times x plus 3. Maybe I'll save the distributive for the next step. These x plus 3's cancel, leaving you with negative 3 and x minus 2. These x plus 3's cancel, leaving you with x minus 2. And we have negative 1 and x plus 3. So our hope is that this crazy mess is just an x. I would wait until this step to distribute. This is too confusing of a situation to try to distribute. Students tend to make mistakes at this step. So this is negative 2x minus 6. Distribute this negative 3x plus 6. X minus 2, distribute this negative 1. Negative x minus 3. The 6's cancel. This is negative 5x. The x's cancel over negative 5. The 5's cancel, and you're left with an x. So give the problems a try. Let me know if you have any questions, and have a great day.